Okay, welcome everyone. Nice small crowd here. That makes it easy. If you want questions, you can ask them and not be buried in the crowd. So welcome to the session. My name is Brian Noyes, and the idea of this session is to give a comprehensive coverage of the navigation mechanisms and APIs in Windows Store applications. Let me get a quick sense of where you guys are at. How many of you are pretty brand new to Windows Store app development? Most of you? Any of you have an app in the store already? Yeah? Couple? Okay. So this is a fairly fundamentals level thing. What I'm going to be going through is some of the different navigation schemes and the UI design guidelines around that, and I'll give a few examples of some of the existing apps to demonstrate those things. Then I'll go through a kind of end-to-end demo showing navigation, dealing with navigation parameters, show you some of the subtle things you may not have discovered even if you've been working with this for a while about some of the underlying mechanisms and what you can and can't get away with. And at the end, I'll also be talking about how it fits into the world of doing the MVVM model view model pattern. Creaky stage up here. I better not walk around too much. Okay, so a little background on myself. I'm from a company called Soliance. We do end-to-end development of projects, architecture consulting, training, that kind of thing. You can look up information about us online there. I'm also a Microsoft Regional Director for the Mid-Atlantic region. That's basically Washington, D.C. and the surrounding states in the U.S. It's a small program. If you haven't heard of it, there's about 130 of us worldwide selected by Microsoft, somewhat similar to the MVP program, which I'm also a part of. I'm also a Pluralsight author. If you haven't checked out Pluralsight, they've got a booth downstairs. You can go down there. I'm actually out of the little free cards, but they've got 1-month passes that you can go down and get a 1-month free subscription, check out some of the content online. Sorry, there's over 500 courses in the library. I have 3 of my own in there. And relevant to this session is that I have 2 courses in there on Windows Store applications, one on kind of fundamentals of the MVVM pattern, and one on using Prism for Windows Runtime guidance. And there's portions of each of those courses that cover navigation as well. Part of a number of insider groups. Probably the important stuff here is my contact information at the bottom. Like I said, we've got a nice small crowd here, so please do feel free to ask questions anytime during the session. And I'll take questions at the end as well. Okay, so what we're going to cover is, first I'm going to talk about some of the top-level concepts around navigation, the page-based navigation system of WinRT, and the frame class that drives it all, the page class, and some of the APIs there, and then I'll demonstrate that stuff. Then I'll also be talking about the application lifecycle, which is important to understand in the context of navigation, because application lifecycle, and more specifically the state management that goes along with application lifecycle, are kind of intertwined with navigation, at least in terms of the startup experience of the user and what page you present and how that page gets rendered initially, and also what you need to do in the context of navigation switches, both with respect to normal navigation while the app is up and running, and also when your app goes away and gets suspended. Then at the end, like I said, we'll talk a little bit about how navigation fits into the MVVM pattern, because the kind of code you'll write and the places you'll put that code is going to be a little bit different in a world where your architecture looks like this instead of just pages with code behind. But the whole first half of the course, I'm just going to focus on the pure WinRT APIs and how to use those directly from your page code behind. Out of curiosity, how many of you are familiar with the MVVM pattern already? Most of you? How many actually use it in your applications? About half. Okay, good. All right. So first thing to understand is there's 2 primary structures of navigation that are predominant in Windows Store applications. And I should clarify up front here too. How many of you are XAML developers? Hopefully most of you. WinJS? Any? Okay, good. So I'm going to just briefly show some WinJS. I think even as XAML developers, it's good to kind of understand that other side of the fence. And I'll just show very briefly, sort of to compare and contrast the fact that even though it's WinJS and JavaScript, it's still the same underlying APIs, and it's the same navigation mechanism that you're dealing with. But I'll mostly be focusing on the XAML side of things in the course here. So the other thing that's kind of an overarching theme here in the session is, I'm focusing on the world that is driven by the modern UI design guidelines. And I'll show once I get into demo mode here a document that you might want to pull down. There's a 300-page document that kind of outlines end-to-end all these design guidelines, and part of those are focused on the navigation mechanisms we'll be talking about today. So that's where this comes from, is that there's two primary forms of navigation schemes that they talk about in there. And one of those, and probably the most common, I would say 95% of the apps that I've looked at in Windows Store apps that follow the modern style guidelines are more the hierarchical means here. And the idea is that you're always going to have a landing page when the app starts up. Call it your home page or hub page, whatever you want there. The documents refer to it as a hub page. But that's that initial experience for the user, the first thing they see when they start your app with a fresh start of the application. And then you may have kind of a hierarchy, and usually this reflects your application model, your data model of your application as well. That you're going to have pages dedicated to showing different parts of information that your application has. And so you might have kind of a drill down experience where first they see high level, 10,000-foot summary type of information about what your app has available. And then they may have major tiles as a common navigation scheme there on that hub screen that they can click on that takes them down to some subdivision. And then from there, there's usually links that they can click on, either tiles or links that take them down to an individual detail page. But as I show here with the one arrow in the middle, there's also typically direct links for prominent detail items that you may have directly on the hub page itself. The other form that's less common is a flat navigation scheme. And this is the idea that there, at least in terms of the top-level data model of the application, there's not this implicit hierarchy. There's just top-level constructs, and there may be multiple instances of a given construct here. So here I say docs, so you could imagine a Metro version of Word, for example, might let you have multiple documents open. And certainly the internals of what that document contains has structure and hierarchy and things to it with headings and sections and so on. But that's not part of the top-level navigation scheme. The WinRT is not really going to be directly knowledgeable of all that stuff. That's just going to be in the rendering logic and stuff of your application. As far as WinRT and the top-level navigation is concerned, there's just a set of peer pages that you'll navigate between. And the main example of this would be Internet Explorer. So let me just demonstrate a couple of these to emphasize some of this. So if I go to, get this responding here, go to the start page here. One example of a hierarchical, actually, let me use this example, is one of the samples from the Prism for Windows Runtime. This one shows the hierarchical model very prominently. It's a product catalog kind of scenario. On your hub page here, you've got top-level categories of products that you can scroll between with accessories, bikes, clothing, and so on. When you drill down a level, this actually shows that you can have multiple levels in that hierarchy. The slide showed one section level and then details, but in this case we have two section levels. There's the first section level are categories, and now this is showing a collection of subcategories, which we can then drill down to, and we see a collection of detail items, and then finally we can click down to an individual detail item. But as I said in the slide, and notice the back navigation in the upper corner, WinRT tracks all that stuff. Every time you do a navigate call, it's building up a navigation stack, and it's tracking what pages have been transitioned between, and it's also tracking the navigation parameters you pass when you do that. So it manages all that for you and gives you easy ways to present this back and potentially forward navigation as well if you want to put a forward error. The other part I was saying is that you can have these direct links. So when I click on a detail item here, we drill all the way down, 2 levels down in that hierarchy to the detail items. So that would be an example of a hierarchical one. And then Internet Explorer would be the main example of a flat navigation scheme. And so here you can see if I right-click in an open area, we've got multiple user sessions, if you will, whatever the concept of a user session is for your application, that are peers as far as the navigation scheme is concerned. They're going to have their own, in the case of the browser, certainly it's got its own navigation within a page that it tracks. But it's a top-level session in terms of the WinRT navigation system that the app is aware of. All right, so let me switch back here. So that's what we're talking about there, and you can certainly mix these. So down at a detail level, I didn't show it when I was in the demo there, but when in the Adventure Workshopper sample, for example, once you're down at a detail level, it's actually using a flip viewer, and you can do the right and left navigation to sequence between all the detail items at a given level in the hierarchy. So then you're kind of mixing and blending these two styles. In terms of commanding navigation and being in control of it, it's important to understand the role of app bars. This shows the weather app, which I'll demo in a little more detail here in a moment, but it's got this top app bar that comes down, and these should be the prominent navigation links. These should kind of be like permalinks in your application, the top level nav that the user should always be able to get to. Now I'll show when I do it live, you can also present in a similar fashion, you can present other more contextually bound navigation links to modify what the user's seeing on the screen, and you can put it up there in a similar style and similar location. The app bar at the bottom is generally reserved for commands that are relevant to the current page, more direct commands to the thing that the user is seeing on the page as opposed to navigational links. You can, this is not a hard and fast rule, these are guidelines, and if you want more kind of high-level guidelines on the design paradigms, I've got a session at 5 o'clock today where I'll be talking about that in the context of business applications. But the stuff down here at the bottom, there's guidelines about what goes on the left and what goes on the right. I'll talk more about that in my later session. But the idea is these are more making direct modifications to what the user is seeing or has selected in the current view, as opposed to taking them to a whole separate page or view. So let's look at a couple more examples just to reinforce some of this stuff. The weather app is actually a really good example of just kind of putting all in one place some of these various navigation paradigms that you want to think about for your own apps. One of the first things it does is the fact that it has this top-level scrolling view, just to emphasize that you don't necessarily have to force the user to go page to page to page to show them different types of information. It's not uncommon in the news app, the weather app, and lots of other apps are doing this. In fact, a more business context-based one is this Push BI application, business intelligence one. And you can see, it's got a similar paradigm that you can scroll through different kinds of information, not quite as many different disparate types of information as the weather app. But you've got that, different categories of navigation. And some of these are just static information, but some of them can cause navigation themselves. If I click on the map, it takes you to the map view, and you can see at the top there, as long as I'm moving my mouse around, it's got this app bar-like thing. It's not technically an app bar. If you had the source code for this, this is actually rendering that the view itself is doing that gives an app bar, a nav bar-like experience at the top. And you can see that it lets me go and select different kinds of maps, and it will render that current page differently. But in terms of the back navigation at the top, you can see the back arrow there. It doesn't remember those changes. So those aren't full page navigations as far as WinRT is concerned. They're just different renderings of the current view. But just from a user experience perspective, so that's consistent for the user, you can do the same kind of presentation that to an end user, I'm sure you've all dealt with people like my parents that they can't differentiate between a browser window or a application window or anything else. It's just a screen to them. So to an end user, this is just different ways to select different screens. But in terms of the navigation mechanism, it's those things that you do a WinRT call to cause the navigation that it will remember as part of the navigation stack. The other thing to show here in terms of app bars, if I right-click, use the window key Z or the swiping gesture from top or bottom, we get the app bars pop out. And just to show it from the map here, you can see the distinction there that one's up there, but when I right-click, it gets occluded by the true app bar. And you can make these things hierarchical. So you can see here the weather maps one has different regions that you can go to, and those are explicit page navigations. So those end up at different places in the navigation stack. So these don't have to be just a single flat button. One app I normally show when I give this talk in the US is the Netflix application. It doesn't work over here, of course, but they actually, get rid of this whole concept of app bar, and they actually have a vertical bar they present on the left-hand side with their prominent navigation links, and it's always there. So it's a good one to show if I could, because it kind of emphasizes the fact that, these are all guidelines. They're there for a reason. They're to give a consistent user experience so that people can discover how to use your app more easily. But if you come up with a different way that works for you and that's prominent and easy for the user to understand, feel free to do that. It's not going to prevent your app from getting into the App Store. Okay, and I guess one other thing to mention in terms of the navigation, let me go back to this AdventureWorks one. If you don't know those keystrokes, it's the Window Tab key, gets you sequencing between the WinRT apps. And the one thing I wanted to show here is in terms of navigation, you need to always be thinking about this concept of split views and filled views. Now, this world is changing. If you didn't see any of the information that came out yesterday at Build, our world is no longer, with Windows 8.1, it's no longer a split or filled or full screen world. You can have multiple splits, and you can drag them to whatever position you like. So here in Windows 8, we're currently constrained to the fact that it's either this or it's full, or we can drag in if I can get the right gesture here. Let's see here, let's bring up one other and then do the split. I can never remember how to sequence here. Anyway, you can see, there we go. So you can get that split and filled view kind of world, but in the Windows 8.1, we're no longer constrained to this. So don't start designing at this point to the fact that in Windows 8, in that design guideline document they talk about specific pixel widths of this split view, and people have been designing to that. In Windows 8.1, that goes away, and you're going to have to be more fluid. It's almost more like the HTML world where you have media queries where you set up thresholds of your own and say, if it's smaller than this, I render things this way. If it's smaller than this, I render them this way. So I'm not even sure, since it was just announced yesterday, exactly what that looks like in code. This is generally run by Visual States. So how many people have dealt with Visual State Manager and Visual States? None. A few kind of maybes. So let me just show, some of that code. Well, I'll do it as I get into the demo. But that's an important part of how this is done today, is that you have visual states declared for snapped, filled, and your default rendering, your normal view, which is the full view. But that world's going to be a little different with this new 8.1 paradigm, because there's not going to be specific sizes that correspond to specific visual states for rendering. All right, so let me go back to the slides here. Okay, when it comes down to actually doing the navigation, there's a few key classes that you're going to use, and we'll show these all in the demo. The center of the universe is the frame class. So the frame class, it's capable of having multiple frames in a WinRT application, but by default, when you use Visual Studio project templates, if you use the Prism for Windows runtime templates, any of those, presume you're just going to have one top-level frame. It is the thing that renders everything you see on the screen, whether you're in full snapped or filled views. And it is fully in control of the navigation of what you see within that frame. So it basically has, it's a container for pages. If you have past, XAML experience, it is a content control. It derives from content control. So it's got a content property that gets set to whatever page is the current page. And that's how it's actually going about rendering things. But in addition to that, it's got the navigation API, so it's the frame class that you'll walk up to and say, I want to navigate to a given page. And it's got a navigation method. It's also got navigation methods for go back, go forward, can go back, can go forward, and things like that to drive the navigation of your application. In addition, I talked about that navigation stack. It's maintaining all the knowledge of where you've been and how you got there is being maintained by the frame class. Then the thing you're loading into your frame is your pages. And these are going to be your top-level UIs derived from page directly or indirectly. You may have some intermediate classes we'll see in the demos. And these are the things that are going to be rendered on navigation. Now, one other thing to understand is, by default, the instancing mode of WinRT is actually more similar to ASP.NET than it is to past smart client technologies. And what I mean by that is that as you navigate from page to page, things are not being kept in memory. As soon as you go from page 1 to page 2, WinRT is releasing all references to page 1 by default, and they will be garbage collected along with all the objects that it holds on to. And when you navigate back, even just a back navigation, a quick forward and back navigation, you're going through a full life cycle of that page object. Now, there is an ability to cache pages in WinRT. There's a flag you can set to tell it you want to cache those, and then the frame will actually hold on to a reference to it so that it can stick around. You need to be a little careful with that. We'll talk about the application lifecycle here, and there are ties to how much memory your application is consuming. The more memory your app consumes, the more of a chance that your app will be the victim of being terminated by the operating system if it needs memory. So the more pages you hold on to so that they don't go through a full life cycle, then the more chance that your whole app's going to be killed and you'll have to restore all your data, as we'll talk about. But the trade-off there is performance. If you have a really intense page with lots of controls and lots of data binding and lots of data that's retrieved, then it may be more efficient and fast for the user to go ahead and turn on that caching. You can command navigation from inside your page code behind. It's because there's a frame property on your base class that gives you direct access to the frame that you're contained within. And then at an application level, the application is not involved in normal page-to-page navigation once your app is up, but it's definitely involved in the initial navigation that once the app launches, you've got to decide what to show. And keep in mind, it's not necessarily always going to be the same hub page because there's different ways to launch your application. There's the normal, user clicks on a start screen tile way of launching your application, but there's also the ability to put secondary tiles on the start screen, which causes you to directly navigate to some specific page within your application. So you may need to intercept arguments that come in, kind of like command line arguments in the old days, that tell you, start the app, but start it and put it on this particular page once you start it. There's also search invocations. If you use the search charm and you support that in your application, your app can be totally not running. The user can invoke a search while something else is on the screen, pick your application, and that causes a launch of your app. But you're going to want to navigate to the search results in that case. So there's a number of different ways you can start up and different destinations you may end up on based on the way you're starting. So you've got that initial navigation control down there. In terms of WinJS, to just kind of talk about the parallel universe there, basically it's a JavaScript world. Nothing's, truly an object. They're all functions, but we treat them as objects. So there's a WinJS navigation namespace, if you will, that acts as somewhat an equivalent to the frame class in the XAML world. It gives you access to command navigation from it. It's got a navigate method with similar parameters to what we see in XAML. It's got navigation events to fire. I didn't talk about it on the screen about the frame, but in addition to methods that let you command navigation, there's also events you can subscribe to on the frame that tell you when navigation occurs. And then there's also tracking the state of the stack and what pages you've navigated between. The key thing to understand about WinJS, there's a lot of misconceptions around this, is when you're writing a Windows Store app in WinJS, you're not writing any kind of browser app. You're writing in the same kind of native managed, compiled, deployed, packaged application as you are if you use XAML and C#. You're just choosing HTML and JavaScript as the way you express that instead of XAML and C#. There is a little more of a dynamic runtime element to the way the JavaScript gets executed once it's launched, but you're really just programming against those unmanaged WinRT APIs of the operating system through JavaScript. It's not a normal browser experience in there. Then in terms of the page level stuff, there is a WinUI pages collection that you have. There's a define method in there that takes this settings object on which it has a ready handler. So this is kind of like the page code that I'll show in the demo that lets you be directly involved when your page is navigated to so you can do initialization. And then at an application level, there's an activated event that lets you do your initial navigation like I talked about in the XAML world. There's one extra piece in the WinJS world. They have this helper class that just kind of wraps up some of the context of navigation. I won't go into a lot of detail on that since there's no WinJS guys in here. Okay, the application lifecycle, this is definitely one of those things that as you get into Windows Store development, especially if you're coming from a background of Windows Forms, WPF, or Silverlight, a smart client world where everything was up and stateful and running all the time, this takes some getting used to. At start of life, if you will, this is right after you've installed the application, or if you've restarted the machine, your app will be in a not running state. And then user launches it, typically through a start screen tile, and it goes into a running state. Once you're in a running state in a WinRT application, it's very much like any other .NET program. You've got a stack, you've got a heap, you've got threads allocated, and the app is up and running, very similar to a managed application. But just keep in mind, your WinRT apps are unmanaged applications at runtime, really. We have managed code that we write that sits on top of WinRT, but ultimately the core of it is an unmanaged process in WinRT. So you're sitting there in the running state, and then the user gets distracted, as users typically do, and they go and check their Twitter feed. So they swipe away from your app on a touch-based device, or like I'm doing on the keyboard there, they window key tab away from it, and your app comes off screen. And by off screen, I mean, fully off screen. If you're snapped, filled, you're still on screen. If you're full screen, you're still running. But as soon as your app is off screen, you go into the suspended state. While you're suspended, your memory is fully intact, which means all your objects, your controls, your pages, your frame, the navigation stack, all of that stuff is just sitting there in memory just like it is while your app is running. The only thing that changes here is all the threads go away. So all the execution time, the processor cycles for your app go away. Now, if the user switches back soon enough, all that happens is those threads just come back. And so if you're in the middle of a for loop and you're on iteration 42 and you get suspended, it just freeze frames in that loop. And as soon as they resume and switch back to your app and it comes on screen, a thread comes back in and starts back into the loop wherever it was. It remembers where the execution pointer was in the stack at a technical level. So in that cycle, basically, hopefully you understand from that description that to the user, the end user experience of that is, if I flip away to Twitter and I flip back to my app should be exactly like it was when I left it. If I'm 5 pages deep in the navigation scheme and I've filled in 5 out of 10 data entry fields, that's exactly what I should see on the screen when I switch back. Now, they can be closed. If you don't know, in the early betas, Windows designers in their infinite wisdom decided we didn't need a closed state anymore. Users should never close their applications. Luckily, they respond to feedback, and enough people said that's a stupid idea. People still want to be able to explicitly close things, and so they added this ability to close things. So Alt F4, or if you're on a touch-based device, swiping from the top of the screen to the bottom of the screen is a close gesture. Then the thing to notice here is it still goes through suspended. So, all transitions out of the running state are through suspended. It's a very brief switch through suspended, but the key about that is there's a suspended event in your APIs. And that's the main thing you're going to react to in terms of presuming that your app might be shutting down in some way. So if it's an explicit shutdown by the user, it'll transition briefly through suspended. The suspended event will fire, and then the memory will be taken away, and it's fully shut down at that point. And then if the user launches again, then these things all come in, all these transitions into running amount to a flag that comes into your entry method in your application class, an on-launched override that you can put in your application class. So you do have knowledge when your app starts of what was the last state it was in when it runs. So you might do something different based on close by user. The general expectation in the design guidelines is that the user experience when coming from not running or coming from close by user should be the same. It's a clean start of the application. Generally, you put them on your hub page. You don't, kind of put them back where they were. But that's fuzzy guidelines. Again, if it makes sense to you and your app and your user scenarios to put them 10 levels deep in the navigation wherever they were last time, you could certainly do that based on close by user. Where things get tricky is the terminated state, because if you go to the design guidelines say that if you get terminated and the user launches again, it should be exactly the same as if they just quickly suspended and switched back without getting their memory erased. But when you go into the terminated state, as I alluded before, it's basically the operating system deciding that it needs to take your memory back while you're in that suspended state because there's some other program that wants to run. So the user went and they launched Twitter and the People app and 2 or 3 games and the Mail app, and your system's running low on memory. So it's got to get memory for the next thing the user launches somewhere. It's going to pick a victim out of the list of suspended apps. And it's totally not predictable in any way you should rely on in your code, but it's somewhat predictable in terms of they're going to pick the app that it's been the longest since it ran and that has the most memory consumption so that they can free things up. And that's why I say you don't want to be overly aggressive about caching things and holding things in memory in your app because it'll make you a bigger target for termination. The reason I say it's tricky is that the user guidelines, like I say that if you go, the user swipes away, goes to Twitter, launches 10 other apps, and then goes and clicks on your icon on the start screen, the expectation is they're 10 levels deep with all their partially entered data and stuff right there on the screen the way they left it. So the user experience has to be exactly the same as resuming from suspension, but the problem is all your memory went away. So when you come back from suspension, you don't have to do anything. In fact, there's not even any events that fire. When you resume from suspension, you don't even know it. Your app just starts running again. But coming out of terminated, all your memory's gone away, all your execution's gone away. The transition from suspended to terminated, there's no events that fire, you have no execution cycles or threads to do anything about it. So it means that basically every time you go into suspension, you have to assume the worst and assume that you will be terminated and do the appropriate things so that you can restore that user experience for the user. That means you have to persist. What page am I on? How did I get here? The good news is WinRT does that part for you. So the part you are responsible for, though, is all the transient data within the current screen. If the user has partially filled in a bunch of fields, they've got a particular scroll position in. If you've got one of those big wide scrolling views like the weather app, what's their scroll position? If they've got selected items in a list view or something, all that state should be retained by you. And it's your responsibility to do that. And I'll show you the APIs that let you do that. Okay, so the classes you're going to be dealing with here in Visual Studio, layout aware page, and these, I say common classes here, these get injected by Visual Studio. So these are not part of WinRT and the APIs themselves. They're really code-genned into your project at design time. And so the layout aware page derives from the page class. And the main methods in there you're going to care about are a load and save state method. And these methods basically give you the opportunity, even though they're called load and save state, they're called that because they're tied into this diagram we just went through. And the idea is that as you transition into the suspended state, you should be saving your state because you assume that you might be terminated and you need to be able to load that state back in when you resume from termination, but only resume from termination. If you launch from closed by user or not running, then you shouldn't be reloading that data even if it's there. So layout aware page has the hooks for that with the load and save methods. It derives from page, so that also gives you access to the frame class to command navigation and to do things like go forward, go back. And the other thing, if you go look at the code of layout aware page, the other thing it does is it cascades visual state changes. So I talked about the fact that there's defined visual states for snapped and filled views that you can use to re-render the layout of your views. So that happens at a top level in your page, but you may have some user control, for example, that's nested down in your page that needs to relay out its own content. So one of the things the layout aware page does is it iterates through all the controls and tells them about the state change so that they can re-render themselves if appropriate. Another class that gets injected there is called the suspension manager. This is the one that's all about persistence of the transient data that you want to save off. It's basically a dictionary of dictionaries at a high level, but it basically keeps a dictionary per page, and you can read and write key value pairs into that dictionary for the transient state of your page that you want to save. It is also monitoring, or really you put code in your application class that I'll show that causes it to save off its state when you suspend, and then when you resume from termination or launch from termination, you put a line of code in there that causes it to restore its state, and then your page can read and write from that in its load and save state methods. So let's take a look at working with all this stuff in a demo. All right, I need to change my screensaver timeout there. All right, so I'm going to go to a fresh application here, and we'll start up. Now, let's get up to the C# thing. I usually start with a blank app if I'm building a real application. These grid app and split app templates are nice when you're first learning and as an example of layout and some of the styling stuff, but you got to strip a lot of stuff out of there if you're building your own app. So I'll start with the blank app template here. We'll call this nav demo. And it starts out with a empty main page in it. Now this empty main page is a little too empty for getting started. You usually at least want the top level structure of the page, so I'll delete this off. And then I will add in a blank page. So we'll say add new item and select the, basic page, not blank page. So we'll call this main page again. And what happens here when I add it is it prompts you here, and this is the point where I said that code generation happens, the injection of layout aware page and suspension manager and a few other things into your common folder. So you want to say yes there. And the key things that got added here, bindable base is a base class for data bindable objects, model objects that you want to data bind to, sets up the iNotify property change pattern for you. But relevant to this talk are mainly the layout aware page I was just talking about in the slides and the suspension manager get injected there. So here in my main page, let me go to design view and build. Okay, and let me just fit it so I can see things. And I'm just going to throw a button on the page for now to cause some navigation. We'll just double click and add a click handler here. So the first thing to point out here are the load and save state methods. Anytime you do a basic page like that, it'll put these in there because it derives your basic page from that layout aware page. And that sets up the pattern that when your page is navigated to, it will call the load state method, and when your page is navigated away from, it will call the save state method. You can see these tick in. For the load state, you get past a parameter. So as you go page to page and you cause the navigation to occur, you have the chance to pass a piece of context to that destination page. So, primary scenario here is maybe you have a listing of products on your main page. You select one of those and cause navigation to the product details. So you got to pass some kind of identifier, at least downstream, for that product. So you have that chance to deal with it here. The dictionary here is the one I said that is managed by the suspension manager. That's going to get passed into your page, and you can read and write your transient data from that dictionary. So if you've got a bunch of text entry fields and a scroll position and a selection and all those kinds of things, you can read and write each of those into that dictionary using whatever keys you choose to identify those things. So here is the point where you would read them back in if you were being navigated to restore the state, and then more specifically, save state is going to be called not only for a normal navigation, but it will also be called when your app is suspended if this is the current page. So this is your chance to save off that transient data before you get suspended. Okay, to navigate, we're going to need somewhere to navigate to, so let me add one more page, and I'll put a lot of thought into this page name, call it page 2. Okay, so just to have something to show, let's go to the design surface here, to the toolbox, and throw a text block out here. And I'll just go change a little bit of the code here. I will give it a name so we can get to it from the code behind. I'll call it TB1, and no, I do not name my controls that stupidly. And then I will put a style on it. Use one of the standard styles that gets injected in that common folder called header text style, which makes it nice and big and fat. Okay, so now we need to actually navigate to that page. Oh, let's actually put some more meaningful text here on page 2. Okay, so we'll go back over to our button click handler here and cause navigation. And as I mentioned, you have access to the frame class. The frame that your page is contained within is a property on your base class, and you can just go to that and say navigate. In that navigate, it wants a type. So remember I said you're going to get a full instance of your page each time you switch. So all it wants is a type because it's going to new it up, present it, and then when you navigate away, it's going to release it. So we'll go ahead and put our type of page 2 here. And notice there's 2 overloads. The second one is this is where that navigation parameter that comes into the load method comes from, is you have an opportunity to pass something. So I won't hook it up yet, but we'll just say hello from main page. Okay, and with just that much code in place, we can go ahead and start this up. We can click on the button. We end up on page 2. You see the back navigation's all handled by the frame. We don't have to do anything explicitly about that. Now, just to show the full life cycle here, let me just set a couple breakpoints here in each of the pages. And let me also show that there's a lower level method that you can handle if you want. Let me put it in the main page for now. There's two overrides you might want to put. One is override on navigated to, and the other one is navigated from. So we'll override both of those and set breakpoints there just so you can see the fact that these load and save states are really just being called by the base class navigated to and from methods. So if we run this now, you can see as it starts up, we're in the main page, we're being navigated to, which dispatches the call into your save state. And it's really just lifting out of this navigation event args. Let me do that again so I can show you the event args. It's lifting out of this navigation event args. One of the things is the parameter, and so that's what gets passed explicitly to the load state there. There's also this navigation mode. The navigation mode you can see is new. When you do an explicit navigate, it's always going to be new. There's back, forward, and refresh. Refresh is mainly used in Win.js applications, but the back and forward tell you if it was, arrived from one of those. Okay, and so we show the main page here. When we navigate off to the other one, you can see first the current page gets a departing message. It gets the navigated from call, which gets dispatched into save state, and then the destination gets its load state or navigated to called. Now, the thing that is wrong with our app right now, if you start with this blank template, it's important to realize that the application class does not quite have everything you need. If I terminate right now, which you can do by switching back to the desktop. Now, let me just point out here, if your app is running normally, the user has launched it from the start screen, simply the fact that I went to the desktop is enough to suspend it. But because I'm running from debug here, they do special tricks under the covers that my app is still running. It doesn't get suspended immediately. So there's this debug location toolbar when you're troubleshooting this stuff that's very useful. Check that, and you get this bar up here where you can programmatically or debug-wise cause suspension, resume, and this last one, which is poorly named, should say suspend and terminate as opposed to shut down. So if I terminate my app right now, remember it's sitting on page 2 right now, and then launch it again, you'll see, notice at the top here, we're coming into main page. We really should be coming into page 2, so I'll just run past my breakpoints there, and you can see we land on main page. And that's because the blank template doesn't have the hooks in it for using the suspension manager correctly on startup and shutdown. That's the one downside to using it. But that's easy to fix. If we go look at our app code behind, you can see that first off, there's a hook for the suspending event that I was talking about. And in there, there's a to-do comment that says save state. And then up above, in the onLaunched handler, there's a to-do here if you're coming in from terminated. So you can see this is a flag, as I said, that comes in the args to your onLaunched handler. If you're terminated, then you should be restoring that state that was saved off on suspension. So there's a to-do comment there. So the easiest way to get that in there is just go create one of the other app templates, the grid template or the split template. And the reason they don't have the code in there is realize that suspension manager didn't come into being until later when we added our first basic page. So they can't put a dependency in the app code on it or it wouldn't compile. So we'll just go in here and steal a couple chunks of code. Create one of these, drop into the app code behind here. And you can see there's a little chunk here that deals with suspension manager in the launched. So we'll just copy that over to our nav demo and basically replace this block. And you can see the first thing it's doing, let me just resolve here. First thing it's doing is it's doing a register frame. So I said it's a dictionary of dictionaries, and actually it can have a separate dictionary of dictionaries for multiple frames if you were to have more than one. But as I said, most Windows Store apps, pretty much every sample I've ever seen, only has this single root frame. And then it's complaining here because this is doing an await. All the persistence in WinRT, this is one of those things you have to get used to in WinRT is anything that might take more than 50 milliseconds is the guideline they use. they only expose as an async method. So these are going to read and write data from disk. They fall into that category, and they use the new task-based async pattern. So you have to put async on the method, and then you put await on the thing so that it sort of pauses execution there until that's complete on a separate thread. And then in the suspension, we need to fill in this to-do. So we can go grab the block of code from there. It's just one line of code to save our data on suspension. And we'll pop that in there. And likewise, that's an async call with an await. So we have to make this an async method as well. Now our app should behave correctly. Actually, let me kill all those breakpoints so that it stops breaking on those. Okay, so we'll run again. Navigate, go suspend and terminate. And then start it again. And you can see we land on page 2. And not just we land on page 2, but notice the back arrow here, the full navigation stack has been retained by WinRT as well. So each time you navigate, it's remembering all the pages you've come from. It's also remembering the navigation parameters that were passed to them. And it saves all that off automatically for you as long as you make those calls. That's what that register frame call set up, is it made it so that all the state that the frame maintains itself will be persisted through the suspension manager. All right, so that's the basics of the kind of nav to and from. One other thing I want to show here is a little bit more about the parameter passing. So I had already hooked up here that when we navigated, I was passing a string here. You know, the simple, straightforward thing would be we could go in here and say tb1.text equals navigation parameter.toString. And this is that piece of context you can pass as you navigate. And then we should see that replace the string in page 2 as we navigate. Now, what you might be tempted to do, and I've done to myself and thought I was good to go and then later discovered I was hurting myself, is you might do something like this. Let's add a class, call it product, and presume that instead of just, you know, a button on my main page, I now have a list of products that I'm showing. So I'll make this a public class, put a couple properties on it, maybe an ID and a name. Whoops, didn't work out too well. Let's try that again. String, name. Okay, and then what you might be tempted to do is something like this. You know, you would grab the selected item out of a list, probably, but I'll just new one up in line here. We'll see ID is 42, of course, and name. Let's see, what's a product name we're all very happy with this week? Our Surface Pros we're all buying, right? Okay, and then we could pass P here as our navigation parameter because that's just declared as type object. And then we would have to change our destination code a little. We could cast the navigation parameter to a product, say as product. I should do a null check here, but for speed I won't bother. And then I would say p.name. And you'd think you were good because this would work and you'd have no problems and you'd navigate and the data comes through and you could data bind to that object and do all kinds of stuff. Until you actually fully test your application and try doing this and suspend and terminate. And then boom. Okay, and then you get this nasty error that says H results and COM errors, and you know most .NET programmers, even us gray-haired guys that did lots of COM back in the day, run screaming from the room because we don't really want to deal with COM anymore. What it's basically complaining about here is you're passing a managed complex object as a parameter, and I just mentioned a little while ago that when your app suspends, the frame is going to try to persist all of its state, which includes all the pages it's been through and all the navigation parameters that got to those pages. The unmanaged APIs down in the operating system don't have enough type information to be able to serialize this complex managed type for you. So it basically means even though you can get away with it there, and in fact, I could run past all this, you know, if I wasn't in the debug environment, catastrophic failure, that probably doesn't sound too good. You know, but if I was launching this as a user, they wouldn't see any of that crap. It would just seem to shut down. But what they wouldn't get is the consistent experience. They would always get a fresh start of the application because none of that state was saved off because of that error. So Don't pass complex parameters is the bottom line. Stick to primitives, strings, integers, GUIDs, things that the unmanaged code knows how to serialize properly. And then design your pages or their view models if you're doing MVVM to go look that stuff up fresh when you get a navigation, either from some cache or by making a service call. All right, so that's basically it for the basics in XAML. Let me just quickly, for comparison's sake, show you the parallel universe of WinJS. We'll just say File, New Project, go into those other languages, JavaScript, Windows Store. Oops, what happened? Okay, so I'll do a grid app here just so I don't have to code anything up on the fly. I just want to show you, that even though it's WinJS, it's really the same stuff. So up here in the app JavaScript that you start with, you've got an activated event. That's equivalent to your onLaunched event in XAML. And you can see what they deal with here. They've got an activation kind. I showed that flag in there that tells you or I mentioned it at least in the slides, that it tells you, are you starting fresh and so on. You've got an application execution state. These are really just wrapped, unmanaged enumerations from the WinRT APIs themselves that are coming into your JavaScript. And then ultimately you do a nav.navigate call. You can see nav up here is just pointing to WinJS navigation, kind of like an alias in C#. And you call navigation with a destination that's a URL in the HTML world, but it's just a relative URL to a resource really within your compiled packaged application. And this one has an overload as well. You can see that you can pass some parameters, some state in this case. If you go deeper into the app, it's got just to show you it running, it's exactly the same as the grid app in C#. It's got the groups. You can go down to a group, and you're one level down in the hierarchy, and you go down to a details page, and you've got the same navigation paradigms here. So the code for the navigation has similar things that we can go down to a page level for the grouped items here into its JavaScript that's effectively its code behind. And you've got this pages defined that I mentioned in the slides that takes an object literal here. One thing on that object literal is a function that's called ready that gets invoked as that page is loaded. So that's your opportunity to take in an options parameter that is the parameter passed by whoever navigated, do something with it to initialize your page. And then you can also navigate, somewhere else. Here we're navigating down to a detail page, and we're passing parameters in the form of a JSON object, basically. So similar concepts out there in the WinJS world. Switch back to slides here. All right. In the MVVM world, things get a little bit different because you really shouldn't be doing all this junk in your code behind. The idea in MVVM is that your view, your page, is just about the structure of what you put on the screen. Ideally, you have zero code behind other than a constructor with the initialized component call. In the real world, it's not always zero code. You might have to have some code that directly manipulates elements and does some animation or things like that. But it should be code that is just affecting the rendering of the screen, if you will. Not any logic to do with data access and command handling and navigation and things like that. The place that kind of logic belongs in MVVM is in your view model. So it really should be your view model that's in control of navigation and decides when do you navigate, and is often nested in conditionals that said if this is true and that is true, it's Tuesday and the sun is out, then we allow the user to navigate to this page. But if they have unsaved data on this page, we need to prevent them, prompt them, and then eventually we get around to the line of code that actually navigates. So that kind of logic in an MVVM app, you want to be back in your view model. And ideally, you want that code to be testable, unit testable, meaning that code should not take direct dependencies on anything that won't behave correctly in a unit test environment. And that includes things like WinRT objects, such as a frame. Likewise, navigation awareness, as you navigate to and navigate from pages, their corresponding view model is the place that should be loading data, populating properties that are going to be data bound to from the view, and then when you navigate away, that may be your trigger to go call a service and persist that data more permanently before you navigate away. And the state management tied into that, like I said, the loading and saving a state, instead of doing that in methods in the code behind of the page, the state's always managed by the view model and just offered up through properties for data binding in an MVVM world. So all that code needs to kind of live down in the view model, but the problem is you saw the APIs are all really resulting from things happening down in the page base class and in the frame class itself. So you shouldn't be taking, a crude brute force way to deal with this would be you could pass a reference from to the frame from the page to the view model, hold on to that in the view model and command navigation from there, subscribe to events on the frame, and you could do it that way, but you'd be completely ununit testable at that point, and you'd also be taking direct dependencies on UI objects in your view model, which kind of subverts the whole MVVM pattern. Likewise, in MVVM, you've got these things down at the bottom that are often there. You could put, in a simple app, you could put all the logic in your view model, but if you've got multiple view models that all depend on, say, product data, then you don't want to re-implement the code that goes and makes service calls to go get that data. So you may abstract that out to a repository that gets the data, and then each of the view models can just go to that same repository as a singleton and get the data out of the repository. But as soon as you do that, that implies you're holding stuff in memory in that repository typically, and that becomes more state that you have to worry about that's transient state. Now something like a product list is maybe not a good example, because that's something that if you relaunch your application from termination, you could easily just make a service call and repopulate that cache. But if it's stuff like the user is entering orders and they haven't pressed the submit button yet, you're going to be caching those changes in memory, possibly in something like a repository. So those kind of transient changes are also state that you need to manage as you navigate away from a page. You need to save that state because you have to assume you may never come back to that page before you're terminated. And certainly when you suspend and then potentially terminate, you have to save your state there as well. So one easy way, the most kind of packaged and easy way to deal with this at this point is a set of guidance that just came out. It's called Prism for Windows Runtime. How many people were in my talk yesterday, out of curiosity? Okay, about half. Okay, so some of this will be a little bit of review of this, but I was going fast yesterday anyway. So Prism for Windows Runtime, it's from the Microsoft Patterns and Practices group. They're the ones that put out Enterprise Library and the application blocks, and the previous version of Prism, which was Prism 4.5, is the most recent release for WPF and Silverlight. This name is kind of unfortunate for two reasons. One is that there's now this big news story in the US and the world, I guess, about Prism, all capitals, the evil NSA stealing all our data. Okay, so bad name for that reason. We're not the evil Prism. It's also a bad name because this Prism has very little to do with the previous Prism from Patterns and Practices, other than being developed by the same team. I was involved since Prism 1 on the other side of things, and I was directly involved in the implementation and design of this. But this is basically guidance as a whole. It's guidance for how do you go about building maintainable, testable, loosely coupled applications for WinRT in the context of a business application, either business to consumer or line of business type applications. The place you can go to get this is prismwindowsruntime.codeplex.com is its landing place, and then on its page, it's got some links to get to the code, the documentation, and so on. The part of this I just want to show briefly in this session is the parts relevant to navigation. So basically what it has, because of this, kind of pushing all the responsibility down into the view model, you're going to need some code that makes that easy to use and doesn't leave it up to you to figure out how to structure that stuff. So what Prism has relative to navigation is, since the frame is the center of the universe as far as WinRT is concerned for controlling navigation, subscribing to events about it and stuff, we need to make that stuff accessible to your view models, but we don't want you directly coupled to the frame class as I talked about. So what Prism does is it wraps the frame in this thing called the frame navigation service, puts an interface on it so that you can just depend on the interface and be mockable or substitutable in a unit test environment. So this thing just wraps the frame class. You can inject it down into your view models, either through manual dependency injection or through a dependency injection container. And it basically exposes the same kind of control that you would have directly using the frame class, specifically a navigate method, go back, can go back, and so on. Then at the view model level, what we have is the view model base class that you will typically derive your view models from, implement an interface called iNavigationAware. And iNavigationAware is the parallel universe, if you will, of the load state and save state methods that you saw in the page code behind with layout aware page. So the way this thing works is that the frame navigation service, because it's wrapping the frame, each time a navigate call happens, first off, it's delegating the call down to the frame to actually cause the page level navigation, but it's also basically looking at the page that it's about to leave, so it gets the content of the frame before navigation happens, and it tries casting the data context of that content. So realize the content of the frame is going to be the current page. If you're doing MVVM, the page.data context should be a reference to your view model. And if your view model implements iNavigation aware, then the frame navigation service can cast that reference to that interface and call methods on it. So the two methods that iNavigation aware exposes is onNavigated to, onNavigated from, similar signatures to what I showed in the code behind of the page that will pass those navigation event arguments down to it. So you know about the flag of what kind of navigation is it a new, forward, or back, and you get the navigation parameter along with that. So basically you can use this as your trigger point to initialize your view models, go retrieve data from services, or to clean up because you're being navigated away from, and realize the same thing happens here, that it's not just normal navigation, it's suspension as well. So when you get suspended, onNavigated from will be called, and you can do some cleanup there, and saving of state more specifically. The thing we do to make the saving of state more easy, since it's going to be maintained down inside the view models or possibly a layer down in those repositories or services, is we've got two facilities. One is called restorable state attribute, something you can put on the individual properties in your view model, and I'll show it in the code here. And then there's a top-level singleton service at the application level called session state service. This is the MVVM equivalent of that suspension manager that I showed before. And literally, we stripped out some of the code from suspension manager and just kind of wrapped it in a more MVVM-friendly manner. So session state service is persisting data when suspension occurs. And then when the app resumes and it sees that it's resuming from termination or launching from termination, then it will read that data back in and repopulate its cache. So you can basically take a dependency on this session state service and do the same kind of reading and writing of dictionaries that I showed in the page code behind, but you can do that from anywhere in your app, such as the view model or further down in your services. So it takes care of that suspend, launch from terminate persistence, and you can take dependencies on it. So let's go ahead and take a look at what this looks like in code. So what I've got here is the Hello World quick start. Let me just show while I'm in demo mode here. If you go to prismwindowsruntime.com or codeplex.com, if the network's still working for me. Drink here. So these are the links here that I mentioned. The important one is the code link is going to take you off to the Windows SDK samples. So they actually wrap this up and ship it officially as part of the Windows SDK now. That put a certain quality bar on this code that the main sample app, that AdventureWorks shopper that I showed earlier with the product catalog, that had to go through the full approval process as if it was going to go into the Windows Store. So, you know, it had to be well styled, it had to be well structured, and so on. Now, there's some code we wanted to write that we call quick starts that are just simple, straightforward. This is how you use a particular feature of Prism. Those don't meet the quality bar for getting into the SDK samples. So that's what the downloads link here gets you, is just the quick starts. So if you want all of Prism, you really need to go get the code over here and get the downloads here, and then you've got all of Prism. So what I'm showing is earlier I showed the AdventureWorks shopper. That's the main sample app that comes from the code link. And now I'm showing the Hello World, which is one of the quick starts that comes down from the other link. And mainly what I wanted to show here is, you know, first off, I can show it running. It's not, you know, super impressive, but it's similar to what I built up before. So we've got a 2-page app. This one actually does some data binding just to show the MVVM structuring, that we've got a view model that exposes a list of strings in this case, a list view and the view that's data bound to that list. But nothing really changing there that we care about in terms of navigation or application lifecycle. But then we navigate over to this page, and the difference here is, you know, this navigation, when you're doing MVVM, shouldn't be event handling in the code behind. it should generally be something like a command handler inside of your view model. So this button has a binding hooked up to a command exposed from a view model, and the command handling logic is down inside of that view model. In this case, it's very simple, one line of code type of thing, but like I said, in a real app, it's probably surrounded in some cases by some conditional logic that says, should I navigate, what are the criteria, and that's the kind of code that you want in a view model where you can test it. So once you get over here, the other thing this app demonstrates is this application state, transient application state here. We've got two fields. It's a little hard to read that small font up there, but the first one basically says this is state maintained by the view model, meaning properties within your view model, which could be just, in this case, a simple string property, or it could be a model object exposed by the view model. So it could be a customer or product or a whole object graph that you're data binding to some particular property down inside of that object graph. And the second one says user input retained in a repository. So this is that lower block in my diagram that there's some caching going on, orders that you've entered but not submitted type of scenario. And that's all transient data that if this app gets suspended and terminated right now, so if I go to Visual Studio and I do the suspend and terminate thing, if the right thing happens here, then all that data is retained. And in fact, if you're using the Prism mechanisms, we launch again, we land on page 2, all the transient state is there, as well as the navigation stack. Okay, so the way you get that done with Prism, I'm not going to go into all the MVVM structuring of it for time's sake. If you want an expanded version of that, I mentioned yesterday I've got a full Pluralsight course on this, on Prism for Windows Runtime you can check out. If you're not a Pluralsight subscriber, head down to the Pluralsight booth and they'll give you that 1-month subscription card. You can check it out. I've also got an article series. If you go to short link is tinyurl Prism RT series. And that will take you to the first article in my series, which is kind of an intro level. But over here on the right, you can see nav links. And there's one that covers navigation as part of its topic. And there's one that covers app state management. So if you want kind of a written form of the stuff I'm covering now, that's a good resource to go to. But basically what we've got here is, first off, in the main page view model here. So first off, in the code behind the pages, notice it's the ideal MVVM world, basically no code other than the constructor on either one of these pages. And so all the logic goes down in the view model. And what the view model has to do is it needs to be able to control navigation when that button is clicked. So first we expose a command that we can data bind to from the view, and the command handler is hooked up in here just using a Lambda expression. But you can see it's basically making a navigate call through this thing called iNavigation service. That's just basically a thin interface wrapper, a facade over the frame class to dispatch your navigation calls. The other thing that's a little different here is remember the navigate calls on the frame, we passed a type. Well, passing a view type down inside of a view model is really technically violating the MVVM separation of concerns. A view model should not be directly coupled to a view in any way, either type or instance. So what we did is we put a kind of layer of indirection here that you can pass a token that is really just going to be translated into a type based on convention. So the convention is it's going to tack page onto the end of whatever you put here, assume that is a type, and it's going to look for that type in the .views child namespace of the current project. If you don't like that convention, you want to put your views somewhere else, you want to factor them all to a separate library or something like that, all you need to do is at a application level, there's an override up here. I'll just go to the bottom here. You can override get page type, and each time a navigation call occurs, whoops, that was weird. Override get page type. Each time a navigation occurs anywhere in your app, typically from inside your view models, that page token will be passed in here, and you figure out how to return the type. So you could have some big hairy switch case statement, or hopefully you have a convention that you can just say, go look in this namespace and tack this onto the name of the token, or just use the token directly as a full type name if you choose. Okay. So that's the navigate call. Also notice while I'm up here at the app level, we've got our initial navigation happens up here. So when you're using Prism, you'll use a base class for your app that we have called MVVM app base. It's got a abstract method you have to override called onLaunchApplication, as opposed to the onLaunch handler that you would in a layout aware page. And then you do your navigate call here again using a page token and optionally a parameter there. So that's the basic navigation, what it looks like in Prism. You just take a dependency on this navigation service. Now that's got to get down into your view model somehow. Not going to get deep into dependency injection here. This particular example shows how to do that without a container. We have a view model locator in Prism that's doing the hookup of the views in the view models, and it's got a couple of ways to override the process it uses. This register method gives you explicit control that says, if this is what I'm navigating to, here's a factory method in the form of a Lambda expression to new up the view model and pass it whatever parameters it needs. So this is manual dependency injection. And the place this navigation service comes from, you can see, is it's a property. It's a singleton newed up by this application base class. So you can just pass it down from the app base class. If you're using a container, what you would do is register this instance with your container so it injects that for you. In terms of the state management, if we go over to the user input page view model, those two data entry fields I had, you can see all we need to do is on any properties exposed by the view model, we can just put a restorable state attribute. And this basically will auto persist the view model base class. You do have to derive from our view model base class, but it's being notified of those suspended events, and when you launch from termination, it's going to use the session state service that I'll also show under the covers to read and write all these things into that dictionary that gets persisted and restored for you. So all you have to do is declaratively say, this is something I want to retain across a suspend terminate cycle through an attribute. In this case, we're showing just a string. If it's just a primitive, that's all you have to do. If you were to put something here like a product, a complex object, ultimately, under the covers, the session state service, like the suspension manager, is actually using the WCF data service or WCF data contract serializer to do the serialization, the persistence of that stuff. And that object needs to know about the types it's serializing. So what you have to do is an extra measure if you're putting that on a complex property type, like a model object, is this method here. You override called onRegisterKnownTypes for serialization. And in that method, you would go to the singleton session state service and say register known type and pass in, for example, type of and say product there. So this is the way you make that serialization engine aware of any complex types that you're going to try to persist that way. And then the other thing you can do is down inside of a service, such as our data repository here. If you have things down in there you're caching, such as orders you're queuing up before submitting, what you can do is take a dependency on this session state service, which again gets injected either through a container or manually as a singleton from your application level. So it's another service started up by the application base class up here, and we can just inject it down into that repository when we start that up. And basically what it exposes is a session state property that is a dictionary. So you just read and write your key value pairs into that, and it will be auto-persisted and auto-restored for you when you come back from termination. So those are the key facilities of Prism in terms of dealing with all this stuff. So let me switch back here and wrap up. Okay, so some resources. Like I said, the Modern UI Design Guidelines, I didn't show it here, but if you just search on Windows 8 User Experience Guidelines PDF, you'll find there's that 300-page document I mentioned, but this is the more online HTML form of that that you can also browse through. My series on Prism and my course there, if you want to reference those. I'll stick around if there's any questions. Again, make sure you get some free Pluralsight time down there by going to the booth. Enjoy the rest of the conference, and most importantly, please do fill out evals. Let me get the code up here. Also, I mentioned my session this afternoon if you want to talk high-level conceptual stuff on design guidelines. But let me get to the QR code that if you want to scan that. Please do fill out evals. We've been getting a really low number of those at the conference, and those are important both to me and to the conference. So thanks for your attention, and enjoy the rest of the conference.